Let's talk about polygons. This chapter is about polygons and special polygons, especially parallelograms. We're going to start with just regular polygons. So it says, in a convex polygon, no point on the lines containing the sides of the polygon is in the interior. So when we talk about convex, we're talking about, so this is concave, this one that I'm crossing out. This is a concave polygon. Convex is going to be these three are convex polygons. A regular polygon is a polygon that is both equilateral and equiangular. That's regular. So when we talk about triangles, we talk about equilateral triangles. So equilateral triangles are regular because they're equilateral and equiangular. When we talk about like a regular pentagon, we're talking about a five-sided figure that has all the sides of the same length and all the interior angles are going to be the same. And the exterior angles will be the same as well. So an equilateral triangle is a regular polygon with three congruent sides and three congruent angles. The sides of a regular polygon are congruent. A right triangle is not a regular polygon because it's a 90-degree angle, which means the other two angles add up to 90. They are complementary, so they are not, you can't have all three angles the same. And an isosceles triangle is not always a regular polygon, but remember, isosceles can be equilateral, or equilateral is isosceles. So sometimes if we have a triangle that we think is isosceles, sometimes it's actually equilateral. And so let's talk about different polygons and make sure we know what they all are. That if we have a three-sided figure, we know that's a triangle, and a four-sided figure is going to be a quadrilateral. It's not necessarily going to be a square or a rectangle, but we're going to say it's a quadrilateral. And I'm just going to kind of give you the most common ones. That five-sided is a pentagon. A six-sided is a hexagon. All right, so again, I'm just going to give you the most common ones. Our seven-sided is a heptagon. So you might think sept. Sometimes you see that, septagon, but it's heptagon. Eight-sided is an octagon. A nine-sided is a nonagon. Sometimes we just say nine-sided. 10-sided is a decagon. You can remember a decade is 10 years. And then a 12-sided is a dodecagon. And don't ask me to draw those because I can't draw them. And then if we have other sides, like a 20-sided, we would just say 20-sided figure or 20-sided polygon. So these are all polygons. Obviously, three-sided is a triangle, which I didn't write that down because I don't think I need to. So these are ones that I think that you need to know the names of them, especially like hexagon, octagon. We use those a lot, so that's important. This says, let's see, where are we at? It says write equiangular, equilateral, or regular to identify what each hexagon. So this one we can see is equilateral because all the sides are the same length. This one, all the angles and all the sides are marked. So this would be a regular hexagon. And in this one, they only marked the angles, so we would call that equiangular. Okay, so you just have to look at what it is. They're really all regular because that's what's going to happen. But those are specifics. Okay, let's get into the a little bit more about polygons. When we have polygons, we have the interior angles of a polygon. So remember, when we have our triangle, the sum of the interior angles is 180 degrees. So when we have a polygon, like a something not just a triangle, because right now we've just dealt with triangles, we're going to use the formula n minus 2 times 180, where n stands for the number of sides. Okay, so n is the number of sides in the polygon. And so if we have a regular polygon or a regular n-gon, we're saying the measure of each interior angle. So this is if we have a regular, we're going to take that n minus 2 times 180 and we're going to divide by n. So that's what we're going to use for a formula to figure out how many degrees total are inside that polygon. It says when n minus 2 equals 1, the polygon, well, that's a triangle, because that means there are 3 sides, because we're just going to say 2 plus 1. N minus 2 equals 2, that means n equals 4, so that is a quadrilateral. It could be a square, it could be a rectangle, it could be a rhombus, it could be a kite, it could be a trapezoid, so it could be any of those shapes that have 4 sides. All right, let's do an example. And so this example says, use the justification below. What is the sum of the interior measures of a 17-gon? So we have a 17-gon, which means n is 17. So I'm just going to go n minus 2, and it doesn't say regular, it says the sum. So I'm going to say n minus 2 times 180. 17 minus 2 times 180 means 15 times 180. And 15 times 180 is 2,700. So that means the measure of the sum of the measures of the angles of that 17-gon, which is what this would look like, I guess, is going to be 2,700. So we're going to say n minus 2, which was 17, which was 15, which gave me 2,700. Okay, so this one says we're going to draw diagonals, and when we draw diagonals, that gives us an idea, too, of how many diagonals we can have in a shape. A diagonal is going to go to a non-consecutive side, or a side that's not right beside it. And this is really hard to do, and it's very hard for me. So it would be like here, 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 and so on, okay, and it would go all the way around. And that just says to check your answer, and the reason you do that is then you see how many triangles you have inside the shape. So if we have a hexagon, oops, okay, that's quite the hexagon, 1, 2, 3, 4, 5, 6. Okay, if we have a hexagon, we're going to draw diagonals as 1, 2, 3 diagonals, which means we end up with 1, 2, 3, 4 triangles, and 180 times 4 is 720. And so that also we can say n minus 2 times 180, which is 4 times 180. So look at that, 4 triangles, 4 times 180. There we go. That's why they have this formula. That's where this formula came from. It says, what is the measure of each interior angle in a regular nonagon? So in a regular nonagon, regular means all the angles are going to be the same. So we're going to use this formula here. Okay, so that's each angle, interior angle, in a regular polygon. Okay, so we're going to say 9 minus 2 times 180 divide by 9, which is 7 times 180 divide by 9. Well, 9 goes into 180 20 times, and so I can kind of simplify it that way, because 9 goes into 180 20 times. And so that gives me 140 degrees. So the measure of each interior angle in a nonagon is 140 degrees. And what you're going to find is that the bigger the polygon gets, the larger each interior angle is going to be, especially in a regular polygon. We start with a triangle. In a regular triangle, which is an equilateral, each angle is 60 degrees. In a square, which is a regular quadrilateral, each interior angle is 90 degrees. And then we get up to pentagon and hexagon, and it just gets bigger and bigger and bigger. So we'll find that that's the case as we go. This problem asks for the measure of angle G in this quadrilateral. So we know there's 4 sides. So 4 minus 2 times 180 is 360 degrees. So there's 360 degrees total. So basically what I'm going to do is I'm going to say 360 minus the sum of those three angles, and that's going to give me angle G. Now, you want to make sure you use order of operations and add those first before you do anything else. And so you're going to have 360 take away, should be 258, is going to equal angle G. So angle G is going to be 102 degrees. And so you want to just make sure that you're going to add up those three angles first, subtract that from 360, and that's going to give you that angle G. Because again, a quadrilateral four-sided figure has 360 total degrees. This one says the sum of the measures of the exterior angles of a polygon is 360, and that's the case for any polygon. Any polygon. The sum of the exterior angles. Any polygon, doesn't matter what size. So in this case, these all add up to 360. These exterior angles, remember an exterior angle is outside the polygon. There's one exterior angle for each interior angle. So I know that this is 120 plus 81 plus 72 plus 87 is going to give me the 360. Just like here, I'm adding up all the way around, which gives me that 360. Okay, we're almost done with this video because it's getting a little long, so I'm just going to finish a couple problems. Since a nonagon is regular, its interior angles are congruent. The exterior angles are either complements or supplements of the interior angles. They are supplements because remember, if we have an angle here and then we have that exterior angle, these are going to add up to 180 degrees, which means they are supplementary. Since a nonagon is regular, the exterior angles are also going to be congruent, and you would take 360 divided by 9, which would be 40. Okay, so regular polygon, each exterior angle is 360 divided by the number of sides. Okay, the sum of the measures of the exterior angles of a polygon is always 360. And a regular nonagon has 9 sides. So the measure of that exterior angle of a regular nonagon is going to be 360 divided by n, which is 40 degrees for each regular nonagon. Okay, so you're just going to do 360 divided by n. This last one says an interior angle, she measured the interior angle as 130, so you need to work backwards because the angle sum, we're going to say 130 times n minus 2 times 180 is going to equal 130, n minus 2, sorry. So 180n minus 360 equals 130n. So minus 50n is negative 360. So n is 7.2. You cannot have a fraction of a side. A number of sides in a polygon is a whole number that is greater than or equal to 3. So we need to be able to work backwards. If I said the measure of each interior angle in a regular polygon is 120, and I want to know what the polygon is, then I'm going to use my n minus 2 times 180 over n equals 120. Okay, if that was a regular polygon. So I'd say 120n equals 180, n minus 360, because I'm just going to distribute. And so then I subtract, which gives me negative 60n is a negative 360. So n is 6. So that would be a hexagon has 120 degrees in each interior angle of a regular hexagon. And that's all I've got for this section. Till next time.